Algebra 2, Concept 35, using the law of sines, solving oblique triangles. In Concept 33, you solved right triangles. To solve a triangle with no right angle, that's called an oblique triangle, you need to know the length of at least one side and any two other parts of the triangle. And we can use what's called the law of sines to solve those triangles. We can use the law of sines when we have two distinct cases. So when we know two angles and one side are known. And so those angles and sides can be in a configuration as you look around the triangle of angle, angle, and then a side that is outside of those two angles, or angle, side, angle, where you have a side that is included in between the two angles that you know. There's also, if you know two sides of an angle two sides of a triangle and an angle, side, side, angle, you can also use the law of sines. So the law of sines is in the box right there, and it's a formula that's very flexible. You have probably not seen a formula before with three parts. So the way you use this formula is you just choose two parts of it. And I'm going to rewrite the second bit. So if you notice, we've got the sine of an angle A over length A that corresponds with it. And that equals the sine of angle B over length B and the sine of angle C over side C. Now the second way, so actually I repeated and I should have rewrote this formula in this way with the side lengths on top. Just a reminder that when we're talking about triangles with A, B, and C, the angles are the capital letters, and then the lowercase letters are the sides that correspond with that. So we'll actually just use two parts of the formula, and it will form a proportion, and then we will solve. So let's look at this first example. So we're going to use what we know about the triangle, different cases. So case one, we're going to solve a triangle when we know two angles and one side. So it's either an included or a non-included side. So an included would be angle, side, angle, or angle, angle, side. So in this first triangle, as we look around the triangle at what we know, notice that we know an angle and then another angle and then a side. So that's angle, angle, and a non-included side. So what I do first is when solving a triangle, I list everything that I need to know. So I have one angle that is unknown and two side lengths. Now if I only am missing one angle in a triangle, I can subtract from 180 degrees my known angles to get my third angle. So 180 minus 107 minus 25 is 48 degrees. Now let's look and solve for side A. So the law of sines works in pairs. So A pairs with angle A. So I'm going to set up one side of the formula. I always put what I'm looking for in the upper left position. So side A over the sine of 48 degrees, which is angle A. Now I'm going to find a second pair of known information, and that is side B and angle B. And so I finished my proportion with 15 over the sine of 25 degrees, which is angle B. And now I can solve for A. So what I will do first is I'm going to multiply the left side by the sine of 48. On the right side, I will take 15, divide by the sine of 25, and then multiply that by the sine of 48. And I think let's round to tenths place, so 26.4. Now I didn't say this, but make sure that your calculator is in degree mode and not radian. All right, now let's find C. So let's set up a law of sines proportion. So side C, and we're going to pair it with its angle. So over the sine of angle 107. And then that will be set equal to a known pair of side and angle. So again, we can use 15 over the sine of 25 degrees. We're going to solve this the same way. We're going to multiply both sides by the sine of 107. So on the right, you will take 15, divide it by the sine of 25 degrees, and then multiply that by the sine of 107 degrees. So side C, round to tenths place, is 33.9. All right, now let's try 1B. So we have a triangle and it's not drawn. I always like to draw the triangles. So I just draw a triangle and then you randomly label the angles. It won't always be to scale. So there, we've got angle B is 34 degrees, angle C is 100 degrees, and then side B is 8. So I can tell by looking around that triangle in order that this is an angle side situation. So I can use the law of sines to solve. Make a list of what you need to know. Just angle A and then sides A and C. And now let's do the work. So we know two angles of the triangle, so to find the third, just subtract from 180 degrees. Good, now let's work in pairs and let's solve for side A. So we're going to pair A with angle A. So A over the sine of 46 degrees. And then we'll pair it with a known side and a known angle. So 8 over the sine of 34 degrees. When using the angles, we always use the sine of the angle because this is the law of sines. Now the solve is the same way as the other two problems that we've worked. You're going to take 8, divide it by the sine of 34 degrees on your calculator and multiply it times the sine of 46. And let's round to tenths place again, 10.3. So now let's set up a law of sines proportion for side C. So C over angle, the sine of angle C, which is 100 degrees, and then we can set it equal to that known pair, side and angle again. The solving steps are the same. 8 divided by the sine of 34 degrees times the sine of 100. So round to tenths place, that is 14.1. All right, now let's draw a triangle and just label A, B, and C and fill in what you know and then take a look. So notice as we look around the triangle with what we know, angle and then a side that is included and another angle. So we can use the law of sines to solve. So let's make a list of the things that we still need to know. And then, just like before, if we know two angles and need to know a third, just subtract from 180 degrees. And then set up a law of sines proportion. Let's just start with A. So that will be A over the sine of angle A, which is 51, compared to, and the side that we know is 11. And now we just found out that angle C is 85 degrees, so we'll compare that to the sine of 85 degrees. Again, the solving is the same. 11 divided by the sine of 85 degrees times the sine of 51 is 8.6. And now we can just do it again with side B, setting up a law of sines proportion. So B over the sine of 44 degrees, that's angle B, and then we can just use that pair again, 11 over the sine of 85 degrees. We're going to divide 11 by the sine of 85 and then multiply by the sine of 44 degrees. So again, the law of sines is an excellent way to solve a non-right or an oblique triangle if you know two angles and a side, or if you know two sides and a non-included angle. Case 2 is when you're solving a triangle when you know two sides and an angle that is not included. So we call that side-side angle. This is the ambiguous case because this case can actually result in not forming a triangle in one triangle or two triangles. We are going to, this year, just solve the cases that form one triangle. So the first thing you're going to look for is your known angle obtuse? So if it is, and then you're going to look and see, if you notice, looking right under where it says obtuse, if the side that pairs with that angle is less than the other known side, no triangle can be formed. But if the side that pairs with the angle that you know is greater than B, the third side, one triangle is formed. So that is one situation, one case that we're going to be solving. Over on the right, if your known angle is acute. So first looking, if you compare, there is a possibility that no triangle could be formed depending on the length of A. Or that one triangle would be formed if A would be the same length as the altitude in forming a right triangle. But what we're going to be solving are the situations where there's just one triangle formed. So if angle A, your known angle, is acute, and then the side that pairs with it is greater than the second side, then you'll have one triangle. So looking down below, we are going to solve oblique side-side angle triangles that have only one solution this year. So those are the only examples that you're going to be given. These cases have a given angle that's obtuse, and then the side corresponding to that angle is greater than the other known. Or if the given angle is acute, then the side corresponding to that angle is greater than the other known side. Just to note that in pre-calculus next year, you will learn how to detect side-side angle triangles that have either no solution or two solutions, two possible triangles that could be formed. All right, so let's try one of these. Example 2A, solve triangle ABC with angle A as 115 degrees. Side A is 20 and side B is 11. So draw the triangle. It's always good to see what it could possibly look like. Then make a list of what you need to know. So we need to know the two angles and that side length. So also note that angle A is obtuse, that's our known angle, and then the side that matches with it is greater than the second side. So that we know. So that means only one possible triangle is formed. So let's start by finding angle B. So now we're going to use the formula where we have the sign of angle B in the upper left position. Always put what you're looking for in the upper left. And then we're going to divide that by the length of side B and then set that equal to the sign of a known angle, 115 degrees, compared to a length. So notice how we have to match up those two ratios there. Now the solving is the same. So the sine of 115 degrees divided by 20 times 11. Now you'll get a decimal, okay? And so what this is the sine of the angle. So you have on your calculator, you can use the inverse sign. So you're going to use your second button and the sign, and you will get that on your calculator screen. Then you want to pull back that decimal. So you're going to press second and your negative button, and you'll see ANS. So that means it's going to take that 0.4984, etc. So I didn't round. I just had the calculator put that into the inverse sign. And then your calculator will tell you the angle in degrees. To find the third angle in the triangle, just subtract from 180. And then finally, to find the third side, now set up a law of sines proportion with your unknown being in the upper left. So C over the sine of 35, which is angle C, equals, and then use the known pair, 20 over the sine of 115. Multiply each side by the sine of 35, and then that last length of the triangle will be 13. Here's another situation. So notice that our known angle is acute, but the side that's across from it is longer than the other known side. So this is a case with side-side angle where one triangle will be formed. So let's make a list of what we need to know to solve the triangle. So we need to know all the unknown angles and sides. And then just like the other one, let's start out with finding angle B. So we'll say the sine of B over the length of B, which is 40, equals the sine of 63 over side or A, which is 44. And so now you're going to do your inverse sign on your calculator, so your second and the sign button, and then pull back that decimal, which is 0.8100 with lots of digits, and I don't round. So that's why I do the dot, dot, dot. So your calculator should tell you that second angle is 54 degrees. To find the third, you know what to do. Just subtract from 180. And now that third side, we use the law of sines, but putting the side length on top. So that's why this formula is flexible. Whatever you're looking for goes in the upper left position, and that makes the solving steps very easy. Now, you may notice that C is the same length as A, and you could have known that, but I went ahead and worked the formula just to be sure, because angle C ended up being the same. Those two angles were the same. There, so I just made a correction on angle C, because when you subtract, you should get 63 degrees. And so those angles being the same now, C and A, then the side lengths will be the same. All right, let's press on with another example. So a helicopter is hovering between two helicopter pads. The pilot knows that she flew into the air at an angle of 70 degrees from one of the pads to her current position. So let's just sketch this situation. She also knows that the pads are 50,000 feet apart. She wants to practice her landing, so she comes down into land at an angle of 65 degrees. So if you look at that sketch, this is an angle, side angle situation, so we can use the law of sines. If she were to start descending now, how many feet would she have to travel in descent to come in at a 65 degree angle? So I've marked our unknown as x. So we can set up a law of sines proportion. So x over the sine of 70 equals 50,000, but then I notice I'm going to need to find that third angle. So I subtract from 180, and then I can finish my proportion, 50,000 over the sine of 45. So now I'm just going to, on the right side, divide and then multiply what I get by the sine of 70 degrees. And so she has to travel approximately 66,446 feet. Let's try another real-life application. So John wants to measure the height of a tree. He walks exactly 100 feet from the base of the tree. The angle from the ground to the top of the tree is 33 degrees. So that's an angle of elevation, which I'll mark. This particular tree does not grow at a 90 degree angle. However, it grows at an 83 degree angle. How tall is the tree? So this is an angle, side angle situation, so we can use the law of sines. So I'm going to mark what we're looking for on my sketch, which is x. So now we can set up a law of sine proportions. So x over the sine of 33 equals 100 over, and now I need to find that third angle. I usually don't find it until I have to. So over the sine of 64 degrees, and then the solving steps are the same that we've done this entire concept. 100 divided by the sine of 64 times the sine of 33. So that means the height of the tree is approximately 61 feet high. All right, that concludes the law of cosines. No, I'm sorry, the law of sines notes, solving oblique triangles.